Let's start with our panel discussion. Our panel discussion today is going to be about performance and scale, and we have 4 panelists who need to be kept under check by me. Okay? So we have Siddharth Sharma, we have Dutta, we have Surbhi, and we have Swanand. We shall start with a quick round of introductions. Sid, from your side, please.
Hi, my name is Siddharth. Many of you know me as SVS. That's fine as well. I'm a Rubyist. I did a few things, other things as well. I used to be CTO of Shadi.com. I was CTO of InVideo. Then I took a sabbatical. I've written a book on sabbaticals. If any of you burnt out, come talk to me somewhere. And after that, I decided to become a recruiter. So I'm a tech recruiter now. If I don't have your CV, send it to me. Sorry. Sorry to the sponsors, but I might get some CVs from your people. I will ignore them, of course.
You'll end up placing them on some other company in this room itself, so it's okay. You already have that.
Okay, well, hi everyone. I am Datta. I am hardcore performance engineer. So I have total 20 plus years of experience in performance engineering. Currently, I am working with Coupa as a senior performance engineering manager. So that's all about my introduction, and I'll add some, stuff to it. Regarding the scaling application or performance, right? I'll just add a few things in that. So when I started, right, at Coupa, right? So when we started, it was like 200 customers. Now we are at 4,000 customers. We are supporting, that is the scale. When I joined Coupa as a first performance engineer. Now I'm a manager, and we have 20 performance engineers working with, that is a team scaling. In terms of instances, right, we have EC2 instances. So when I started, that time it was all about 1,000 EC2 instances, and now we are at 3,000 EC2 instances. That's the scale. Thank you.
Hi everyone, I'm Surbhi. I started off my career in IT in 2007 with persistent systems as a Java developer. And then I got introduced to Ruby on Rails because back then startups were really using, Ruby on Rails for development. After that, right now I'm working as a director of engineering and pattern. And it has been an interesting journey wherein I've worked with a service-based company, and in between that I worked for a company called as Applied in Energy Efficiency domain, and now pattern as e-commerce. So I'm really enjoying my journey so far.
Hi everyone, I'm Swanand. I'm your friendly neighborhood geek, and I've been on both sides of the employment, being an employee, a Rubyist, an IC, then a manager, then a CTO, then a founder. I started business, sold them, and then right now I'm running a consultancy for unfucking things at product engineering orgs. And I love, sharing mental models and worldviews. I've got a decently popular blog.
I'm Gautam. Okay. Yeah, I spoke about myself earlier, so I'm not going to get there again. But I'm here to ensure that I ask them questions which are sometimes comfortable, sometimes uncomfortable. And I also want the audience to participate. So if there is, if you disagree with something, one of the panelists says, if you have something to add, please ensure that you raise your hand so that I see it, and I'll have somebody come with a mic, and then we will make it more interactive. The intent of this entire panel is to talk about performance and scale. Okay, but performance and scale has different meanings in every realm of a professional. It could mean, as Datta said, performance and scale of an app. In other words, what you do best. But it can also mean performance of an engineer. How well can you be more productive? It can also mean scaling of engineering teams. So this entire panel discussion is going to encompass all of this, starting with application performance. Now, it's very easy to talk about scale, but I'd like the panel to probably discuss failure. We learn most from failure. So I'm keeping it open. What's the time that you found there you actually had to struggle for any performance, or you know, the stories or scary stories which have a learning from it? I'm keeping it open for anyone who wants to pick up the mic.
I'll start. Okay, so in my 20 years of career, right? So initially, 10 years back, right, it was pure enterprise application. So you are upgrading your code after 6 months, 7 months. That time story was different. Now, when you are a cloud-based company, every week you are upgrading your code. You are upgrading your stack, you are upgrading your code, and definitely whatever kind of testing you do, whatever simulation you do, it is expected and it is given that there will be a failures. There are many, I can talk about that, right? The important thing out of that failure is, right, how easily, how quickly you get into the root cause of that failure and how quickly you recover from the failures. So that is the statement. If you are quickly able to recover, that's very good. Talking about failures, right, there are a lot of failures, but I would, talk about a very, interesting and big failure which caused by, other component, which, so we use MySQL database. Application is written in Ruby, Linux. In Marathi we call it Phukat te Postik. So all that, open source. So MySQL 7, so we were supporting up to MySQL 7. So we have, large database, 2 TB, 3 TB database, a single table size, it has 30-40 million records, and we have written our own query. We have optimized own queries, and we have used a lot of MySQL inbuilt functions parameters. And when we shifted from MySQL 7 to MySQL 8, there was a huge performance issue. There was kind of blocker kind of things. There was some scenarios, there were some queries, those we fixed in Coupa as a monkey patch things. In MySQL, those were already taken care. And those were some, parameters, MySQL parameter. It gave us very hard time. In my organization, we declare the release date 1 year ahead. But that was the first time when we, delayed our release or, production upgrade.
So you're talking about production upgrades
And
for databases also.
Database point of because of the migration, but it is not about what the cost and everything. It is all about the reputation, right? So throughout the history, right, there is no value for reputation, right? So you cannot judge that in terms of money.
So what was the downtime?
Downtime was like less than 1 hour. Okay.
Cost of that downtime?
Cost out of that downtime, maybe we can discuss later, but I am talking about the reputation. So see.
That means about $50 million.
We are talking about the reputation, and, see, whenever I say, so somebody goes and say that, throughout the release so far, so many years, we have not pushed our production upgrade any time. That was the statement we were using, but now we say only once we did that. So that is what the reputation and the failure to me. So it is important.
So talking about just even in part as part of scale, right? There are a lot of debates which happen whether you should be, I'm sorry to bring this up again, but microservice or monolith. Do you all face this query in your daily lives, whether you should be a microservice, which you use a lot of microservices, or should you be a monolith? It's a common debate, but I want a quick idea around that, your opinions about performance of microservices architecture versus sometimes just being simple and monolith.
I'll share two things and set quick context. Back in the day when I started programming, improving performance of an application meant one and only one thing: just buy a faster CPU. You were on 1 gigahertz, buy 1.5. You were on 2, buy 2.5. That was the story, right? And turns out, which I later learned, there is a mathematical foundation to this principle, that just buy a faster CPU almost always works, and it can be mathematically proven. But it's not the case now. If you go look at AWS, Azure, GCP, go and open the web page and look at what type of CPUs are you using. Do you even know what is the gigahertz clock speed of the CPU that your software is running right now? I bet 80% of you may not know. And the reason is that fast CPUs have become commoditized. Almost every CPU offering in the cloud is now 3.7 gigahertz Intel or M2 or AMD CPUs. So that strategy is no longer applicable, which means we need to find other ways to improve performances. Whether it's garbage collection, improving single thread performance of your app, or scaling, which is supporting multiple requests and large loads and accounting for failure. So this is the mental model I think I want to put in everybody's heads, is that CPUs are no longer a running point of contention. It's all about taking the best out of the CPU that you have and then accessing multi-worker loads.
Monolith or microservices?
So same principle. If you have a monolith, you have a single dependency, which is your database. So no matter how you scale your load balancers and compute elements, at some point your train is going to come to a grinding halt at the central database. And if you're splitting your microservices, then you need to split that context window. If two different services are talking to the same thing, that's not really horizontal scaling. And so how many right context windows you have, or in the case of domain-driven design, they're called bounded contexts. As much as you can parallelize. So the true scaling lies in true parallelization, and true parallelization does not exist. So we try to go as close to true parallelization as much possible.
Right. So for me, in the current project that we are working on, like microservices has helped us a lot. And what we have learned is like single responsibility principle that we follow, right? Each service is responsible for one piece of the software or piece of the domain, right? What it's handling. So in e-commerce, we have different pipelines, and each, we have one workflow from end to end, right? And each of these steps is a single responsibility thing. So we have a different service for each. But as you rightly mentioned, right, at some point of time, the microservice, it's talking to a database, and the database becomes the point of contention, right? Now, that's a different challenge, like how do you scale that, right? At this point, we have not come to a point wherein the database is becoming a bottleneck for us because we use a lot of Snowflake, and what's becoming a bottleneck for us is like, because two microservices, they do communicate with each other using sidekick jobs, right? And one of the failure stories, if I can talk about it, is like, for us, orders and inventory is the heart, right? So what happened is like, we were consuming orders, there was a job responsible for it, but we had a different scaling policy for the job. And one day we added, we keep on adding new sellers. So what happened is we got an influx of lot of orders and the job was not able to scale. And why it was not scaling? Because we had scaling based on CPU and not the number of messages in that queue. So that was one of our learnings, very basic things, but we learned out of the data that we were getting, and how we corrected that is like, yes, we corrected it, but how it impacted us, we have seller accounts, and we have this agreement like our delivery rate should be within 85%, and if we do not meet that, it impacts the seller health or the account's health, and Amazon can even shut down that seller. So that's kind of a business loss. That didn't happen, luckily. We were able to recover.
So it did happen, but you're supposed to say it didn't happen.
Yeah.
So the moment you move from monolith to microservice, one of the biggest issues comes with stateful and stateless. With microservices, you cannot maintain state because you don't know which instance of your microservice, which is also scaled on its own, is going to get in. So now for managing state and statefulness, you have another layer of dependency / redundancy / point of failure. How does that impact your performance? I have this way of asking very awkward questions.
Okay, well, so before starting to first point, right, whether monolith or microservices, right? So I'll answer to that. So I think both things are good at their place. See, it is very easy to say that you convert you have enterprise application, 2,000 customers, and convert into microservices. It's not easy. It has a time, cost, and everything. But what I based on my experience, what I'll say, it is important for you to understand what is your customer's workload, how your application works, and out of that, right, how to scale, right? Not microservices, but definitely services can help to scale the monolith application. So those that is about first question. What was your second question?
Stateless, the state management. So you actually have to get into now maybe a Kafka model, messaging, which would not have happened if you were just a monolith.
Okay, actually, can I bore all of you with a little bit of theory? So, you talked about the control layer and coordination of microservices, or let's not call them microservices. In the context of performance, the right phrase to use is parallel workloads. Right? If your workload is not parallel, then we're not really talking about performance. We are only talking about mimicking the org structure and organizational problems, which is, we'll probably come to it later. But in the context of parallel workloads, which is what service-oriented architectures want to solve for, there are two things that we need to consider. Number one is how much of the work must happen sequentially. And this unit of work cannot happen in parallel by nature. That is your primary limiting factor. The technical term you want to look for this is Amdahl's law. Go look it up, write it in your note. And then the second part is how much chatter needs to happen between the workers, right? If all the workers are sharing a CPU architecture, then the message bus on a motherboard is shared between CPUs. If there are 4 CPUs, there's only one single message bus. So if there is any data transfer that is happening, it must happen in a sequential manner. So similarly, if you expand this into a microservice or a service-oriented architecture, services must talk to each other. They must share data. They must pass messages through Kafka. And how much of your entire workload has this message passing element is called the coherence factor. So the more your services and workers need to talk to each other, the worse your performance is going to be as you increase your scale. And so if you want to have a very analytical approach to scaling and figuring out what is your optimal workload, you want to consider your sequential factor, which is contention, and your contention within or communication within services, which is your coherence factor. All of these two factors are together represented in what we call as universal scalability law, formulated by Dr. Neil Gunther. So people who are of nerdy and geeky nature, who want to understand these things deeper, Google it, read it, and then build your worldviews of performance around it.
Somebody needs to summarize that. Yes, please.
I think everyone is talking more about like the performance optimizations around like monolith and like microservices. But I think maybe SVS he wants to talk about, it's not just about optimizing like one's team is working on it. It's also about you have a like team of 400, 500 people, everyone working on a single app and trying to work through it. You have to think about the cost of performance of the people involved versus like just like optimizing for that whole app. So I think that is a bigger factor these days, considering if you're going for like microservices or monolith.
Yeah, microservices is a org scaling, not a load scaling. This thing, you can serve as many requests per second on both kinds of these things, but when you have dozens and dozens of people working on the same few hundred people, at some point it becomes too risky to allow just anybody to just do anything inside just this thing. So it's basically a way of like, okay, if you screw up, you'll only kill a part of my system, right? Not the whole thing. But there was a philosopher, I forget who it was, he said all of man's problems come from his inability to sit still in a room, right? And the two main culprits in our world are the front-end developers and the DevOps people, okay? When front-end developers can't sit still, they go and invent React, okay? And when DevOps people get bored, they go and invent microservices. So if you ask me, we've been played for fools, absolute fools by the DevOps people. Like, okay, I'm only half joking, but like many microservice installations don't need to be microservices. You don't need to know what an L7 proxy is to serve an app on the internet, right? And we tried microservices at Shadi. And we were like, why are we doing this again? Only the DevOps people were unhappy when we rolled it back. So they were itching to deploy what? Envoy. Kya hota hai? Envoy. L7, L6, what is it? Yeah, okay. Chalo.
So basically, scalability, as you mentioned, I mean, it'll get quoted that microservices is not technology, it's people.
Yeah.
People and departments. Where you want to ensure that even single responsibility is with a particular group of people so that only failure is controlled at every given point in time. When you're talking about performance, now that you already got into philosopher mode, performance of an engineer, okay, productivity of a tool, and summarization of what Swanand said earlier could be done using some sort of LLM and saying, can you please summarize what Swanand just said? What is the productivity that you all have seen improve in developers by using Copilot and similar tools?
सब कुछ मैं ही बोलूँ क्या? Okay. Also, in my teams, the biggest improvement that we have seen is the cold start problem and boilerplate, right? I hate JavaScript, but if I have to write JavaScript, I have an LLM do the initial work for me. It gets me off the start. I want to write a document, I'll put in some of my thoughts. The LLM can create a basic point, let's say 5-pointer agenda, then I'll go and expand it with my taste. So this whole cold start or boilerplate reduction has been a massive, massive improvement.